Ah, yes, the unit circle. Not much is more important in pre-calculus than the good old unit circle. Look at it. It's a circle, and there's units on it, and there's points on it, and there's pies and square roots and degrees, and you're like, what the heck, sir, does all of this mean? Teach me, oh wise internet guy. Well, here I am. But in order for us to understand the unit circle and whatever the heck it means, we need to understand two specific triangles, and here they are. Triangle number uno is the 45, 45, 90 degree triangle. Of course, named after its angles, 45 degrees, and this right angle here. It's also called a right isosceles, but, who cares? What matters about this is if this is a right isosceles triangle, these two guys are the same. So we'll call them A. Now, we could use Pythagorean theorem to find out what the hypotenuse is, but if it's 45, 45, 90, there's a shortcut. Whatever these small legs are, you're just going to take the square root and multiply the square root of 2 to that leg. So if this was 5, that would be 5 root 2. If this was 8, then that would be 8 root 2. That's your 45, 45, 90 triangle. Now, the other guy is the 30, 60, 90 triangle. Of course, named after its 30, 60, and 90 degree angles. Okay? The smallest side over here, B, is going to live in between your 60 degrees and 90 degrees. This is fun. If this is B, then your hypotenuse is always going to be 2 times the smallest leg. The second leg, the in-between side, is going to be whatever the smallest side is times the square root of 3. So if this was 8, that would be 8 root 3, and that would be 16. So these special triangles help us figure out specific measurements in this guy back here, the unit circle. Now let's try to take 2 examples and try to understand where these measurements, these numbers are coming from. Let's take this line right here that I'm drawing in blue. Okay? Now if I wanted to, I can make this look like a right triangle right there. So let me redraw that. Okay, what do I know? Well, I know that this guy right here is going to be 30 degrees. I know that this guy right here is going to be a right angle, which means this guy right here is going to be 60 degrees. Do I know any lengths? Sure I do. In every single example in the unit circle, my hypotenuse is going to be 1. Where did I get that number? 1, 1, 1, negative 1, and negative 1, which means if I were to take this length right here and spin it around, the radius of my unit circle is going to remain 1. So in this case, my hypotenuse is going to be 1. This is a 30, 60, 90 right triangle. Now, normally we view this as, all right, well, whatever the smallest side is, my hypotenuse is going to be 2 times that. Let's work backwards. If the hypotenuse is going to be 2 times my shortest side, then my shortest side is going to be 1/2 of my hypotenuse. All right, I can handle that. And if I now know that my hypotenuse is 1, my shortest side is 1/2, then this guy is going to be 1/2 times a third. Well, that looks kind of sloppy, doesn't it? It does. Thank you, whoever said that. So 1/2 times a third can be written out as 1/3 over 2. So this guy is 1/2. That guy is 1/3 over 2. Now, if I wanted to, I could write that as the point where if this is going right 1/3 over 2, and that's going up 1/2, that becomes the point root 3 over 2, not 1/3 over 2, I apologize, 1/2. Okay, let's look at another example. Let's look at an example, let's say, let me get a different color. Let's get my favorite color, green, and look at this guy here. Okay. Now, if I wanted to, I can turn this guy into a right triangle like so. So let me draw that out. What do I know? I know that my hypotenuse comes from the radius of the unit circle, which is 1. I know that if I'm using this guy, it's telling me right here that the angle is 225. Well, what does that mean? 225 starting from this guy spun around means that if I were to cut out 180 of it and only focus on the degrees from 180 degrees to 225, that gives me a right here 45 degree angle. Okay, which means you're 45 degrees. If I created a perpendicular line, you're 90, and I have myself a 45 degree angle, 90, 45, 45, 90. This is 1. Now, this is where the math gets a little weird. If this is 1, we know that if the shortest side was like 15, we would multiply root 2 to get my hypotenuse. So in order to go backwards, I have to take 1 and divide 1 by root 2. Now, we know that it's completely against the law to divide by root 2. So we rationalize it by multiplying the top and the bottom by root 2. This gives us root 2 in the numerator. Root 2 times root 2 is root 2 squared, which is regular 2. So 1 divided by root 2 gives me root 2 over 2. And since these are exactly the same, root 2 over 2. So if I take it back over here, this length is root 2 over 2. This length is root 2 over 2, that length right there. Now, there's negatives all over the place. Why? Well, in order for me to create a point in the third quadrant, I go left root 2 over 2, down root 2 over 2, and that gives me the point root 2 over 2 negative root 2 over 2 negative again. Bada bing. So the unit circle comes from the fact that we have special triangles. Okay, if we don't have to deal with triangles like these guys, like 0 and 1 and 1 and 0, then, we're good. And if we deal with specific angles, like if we were to deal with this 225, which we just did, we can view this as right triangles anyway. And then we just have to remember, 225 lives in the third quadrant. Or if I were to ask you to deal with 300, that lives in the fourth quadrant. So the point is positive, negative. Or if I were to ask you to deal with 120, then that lives in the second quadrant, negative, positive, so on and so forth. So that is the unit circle. At some point, you are going to learn and try to memorize a lot of these measurements, but this gives you just a nice little visual. Thank you so much for watching and enjoying with me. The end. Unit circle.